like a amalgamation of various technologies, starting from electronics, a combination of mechanical engineering, electronics engineering, computer science, robotics, and so many other things. And when we talk about this in the era of Industry 4.0, where a lot of automations are happening and lot of things are getting into different streamlines, so it's very important to discuss. And today, Raj sir also mentioned, it happens to be the National Youth Day in India. We have invited a lot of youngsters, persons who are students who are currently pursuing their education, people who have just started the industry, and lot many other people from different parts of the segment. So I would first like to welcome our CEO, Mr. PVG Menon, sir, to give us the context setting, and then we're gonna begin with the panel discussion, and a lot of things are intact with you. So over to you, PVG, sir. Sir, you have to unmute yourself. You're on mute.
Oh, sorry. Thank you, Varun. Good afternoon to all, and a very warm welcome to our very esteemed panel here of experts to discuss about this arguably one of the most exciting areas of technology today, which is mechatronics. I have just a couple of slides. Let me just share my screen, and you know, me just a second. Is it visible?
Uh,
Yes, sir.
Yes, sir.
yeah.
So before we get into talking about mechatronics per se, let me give you a very quick overview of who we are, the Electronic Sector Skill Council of India. We are, very simply put, the apex skilling body for the electronic sector in India. Uh, Please note, we are a skilling organization. We don't run universities, though paradoxically we work with closely with universities, but we essentially are in the business of providing life skills in electronics to the youth of India. Our background, we are formed by 7 of the leading industry associations in the electronics hardware space. So there is ELSINA, which is the Electronic Component Industries Association. There is MATE, which is the Manufacturers Association of Information Technology, which largely represents the computing industry. The India Electronics and Semiconductor Association. The core membership is embedded software and semiconductor companies, but also quite a few systems companies in there. CMA, which is the Consumer Electronics Appliance Manufacturers Association, the name is self-explanatory. LEDMA, which represents the LED industry, dominated by lighting, of course, and then ELCOMA, which represents the solar industry, and the Indian Printed Circuit Board Association. The way we deliver training, we work very closely with industry. We work with 9 subsectors of the electronics industry, and we have what are called subject matter experts drawn from industry, who constitute what are called national occupation standards committees for each of these sectors. Now, what we do is we take the requirements of each subsector, let's say, for example, contract manufacturing, and then we identify what are the commonly required job roles in there, and then we develop what is called a qualification pack. Qualification pack essentially consists of training material to train the student, train the trainer material, and also question banks to do assessment. So the way we deliver the training is that we have an entire ecosystem of education entrepreneurs who will deliver the training, and then we have a parallel ecosystem of companies who do assessments and certification and stitching the whole thing together, bringing technology elements, keeping these material live and relevant, working with industry. That is what the Electronic Sector Skill Council of India does. This is just a very small snapshot of all the companies that we work with. There are many, many more. Um, and there are several knowledge partners that we work with. This is knowledge intensive business that we are in. And as you can imagine, we work with knowledge partners across the world. Footprint is pretty large. We've been around for 8 years, and in 8 years, we've trained 1.2 million youth, or 12 lakh youth, as we say in India, out of which about 600,000 have got wage employment, and about 225,000 have become entrepreneurs. Typically, let's say we train a young person on how to service an air conditioner or repair a mobile phone, and then they decide to go into business themselves. So that's the way it works. Um, we have over 200 subject matter experts across our 9 areas of the electronics industry. We have a pretty large footprint. India is a large country, and we are present in 29 states and 7 union territories with over 4,000 training centers which are live. And I talked about the training ecosystem. So we have approximately 7,000 trainers who have been trained by the Electronic Sector Skill Council of India. We run an extensive train the trainer program. And for the benefit of viewers who do not know how the training ecosystem works, train the trainer is important because you may be a good practitioner, but you still have to be taught how to teach. And that is what the train the trainer program does. And once a student finishes his or her training, then they undergo a test, assessment, and certification procedure. And for that, we have in the last couple of years, we are starting to go international. 5 of our qualification packs are already certified across the United Arab Emirates, um, and more of them are in the offing. Across the country, we have 13 centers of excellence which have deep know-how and expertise on a particular area. It could be, for example, ozone-free air conditioner servicing, or it could be mobile phone repair, and so on and so forth. Now coming into mechatronics itself, I took the definition, which is it's a multidisciplinary field of engineering, including a combination of mechanical, electrical, telecom, control, and computer engineering. So as you can say, the ikigai is the centerpiece, which includes elements from each of these areas. Um, Widely used in these areas, whether it's industrial automation, aerospace engineering, medical devices, ATM machines, vending machines, and 3D printing. And the interest in this is so hot that I call it the red hot sector. It is expected to grow to $15 billion by 2023 with a very, very aggressive compounded annual growth rate. Present a spectrum of practitioners, users, and experts in this area. And we, as a country, India has huge aspirations to deploy mechatronics technology across our various industry segments. And this COVID-related slowdown has actually been, in a sense, a boom because people have been able to upskill themselves, learn new uh, uh, technologies and skills, and prepare for the coming job requirements that are there in the industry. With that, ladies and gentlemen, any more information on the Electronic Sector Skill Council, please do visit our website. And there are lots of information about how you can reach us there. So going to keep it very short and sweet. I'm going to hand it back to Varun to continue.
Thank you, sir. That was really an insightful. Now, I would like to welcome Mr. Norman from Germany. He is one of the key advisory board member of the European Technical Chamber of Commerce, and we're going to listen from him how mechatronics is useful in this era of Industry 4.0. So, over to you, Mr. Norman.
Good morning, everyone. Thanks for being here. Honored to have the opportunity to talk a bit about the European or German way into Industry 4.0. Let me take the opportunity to share my screen for a second, and we can start. Please give me some advice if the presentation is running.
Yes, sir.
Yeah.
Okay, what you can see here, it's about me. It's just for a second to give you an introduction who I am. I'm not talking about in detail, but as mentioned, I'm a board member of the European Technology Chamber. So we are focusing on bringing technology to the people, always a bit, of course, in relation to the SDGs. And I'll give you a couple of minutes what is important for me and what is important for all the countries around. And then we just say, it's not about technology. That's what's the focus on my speech here right now. It's about collaboration and it's about people. So when we talk in Germany about Industry 4.0, everyone can assume it's more about, technically thinking. It's about autonomy, it's about interoperability and sustainability. So it is in one way very important that you have a infrastructure who's talking to each other and you are the one who's taking the decision. Yes, it's important that everything can speak with each other. But most important is actually that we talk about sustainability. What does it bring to the mankind? How does it help to become a better place in the world to live in? And then we come to decent work and education. So when we talk about Industry 4.0, it's about bridging the gap. So how do I come from my current state to the Industry 4.0? And once we figure out where is our status quo and where do we want to go, we just say digital transformation is about talent, not technology. And this is very important. We do have a lot of technologies around for a while, sometimes for ages, but we didn't figure out yet how to use it. What's the benefit of using this technology? And of course, we do have a couple of technologies that are now on the cutting edge and allowing us to use the technology in our daily life. So it's, of course, quantum. There are a lot of things who are enabling now us to use technologies in the right way. But keep in mind, it is about bridging the gap. It is about talent and not technology. We had a guy in the US right now talking a lot of time, who is first? What I say is people first. It's about investing in people and skills first. We can see on the left side, my friends from the World Economic Forum just announced 1 month ago in a huge white paper what's going happen in the reskilling business, I would say. We will have an increasing demand of a lot of new job roles, and we have a decreasing demand. And what we see is 50% of all employees will need to be reskilled by 2025. That's a huge amount. And that's what we see in Germany. is a point where we see, as one of the leading countries in the world, we need to upskill our people, we need to reskill our people. That's much, much more focus for the next years than investing in any machine. If we do have investments in the corner of our shop floor and people are not able to use this investment, it's a dead investment. What is a living investment? A living investment is investment in people. What we do here, or what we say, is having clusters, having organizations who bring a lot of people together, redefining cooperation, developing new digital business models, communicating digitizing as an opportunity. We have a lot of people fearing the new age of Industry 4.0 because they fear to be replaced by a robot, and they can't see right now all the opportunities. So it's a task of the leadership to tell everyone that using technology makes your job more safe than not using technologies. But this is, it's a hard, or it's a tough way to come into mind of everyone, that using technology is like using a hammer. Maybe 2000 years ago it makes it easier to bring a nail into a wall, so it's maybe easier right now to use a robot as a tool to get an understanding what is important. And of course, always we need to think about what's the impact of using technologies. Does it help for us reaching the sustainable goals of the United Nations? Is it a technology what helps us here to secure prosperity for the region? And this is what is very important. I'll give you a short example. What we have here, it's the Mittelstands campus, one place in Munich. And as I mentioned, it's not about technology, it's about a new form of collaboration. So a lot of companies working together and bringing one instrument into one orchestra. And then everyone working together brings us to play a melody. And this is not about a single solution. It's a big, complex thing we are having in front of us. And this is important that everyone is understanding right now in the future that it's about collaboration. It's about working together. So it's about working together, 3D companies and AI companies, as well as robotics companies. It's not that only one company can provide the solution for everything. Explore, explain, execute. What we figured out in the past is if people can touch technology, if they can see other people working with technologies, they start to think about, okay, it's not hurting, it's not running away, it's just working with me. So it's not, I don't have to be afraid of it. Once they have explored, so this technology helps me, it's very important to get them enabled to use the technology. This is about explaining, it's about education. Once they start, for example, to see, okay, there is a car, wow, mobility is a good thing. What do I need to do for that? I need to take a driver license. Okay, that's what I do in the next step. So exploring, discovering, it's important for me. Afterwards, just figuring out how can I enable myself, and afterwards execution, using what you have learned. The huge gap what we have right now is not exploring. So you can see a lot of things on exhibitions, fairs, and actually executing is not a problem as well, because we do have a lot of shop floors. It's about education in the middle. It's about bridging the gap, and this is what's all about. So you do have touch points, you do have all the things. Let me just, once you have education, you have learning, now we are in the time, in the era, not only of Industry 4.0, we are in the era of upskilling people. What is important? upskilling people is just important to have a digital competence. Why is it important? A lot of things are, even the learning and even the executing, is happen in a digital world. So it doesn't make sense to stick to your study you had maybe 10 years before. You need to be able to switch your mind to lifelong learning. So you are not ready at whatever stage, and then you just work for the next 20 or 30 years. What we have right now is we are entering the era of lifelong learning. So you keep working and you keep learning at the same. There are a couple of things what we use as Drive. It's a digital learning experience. I'm not going too deep, but learning with gamification is, for example, one thing I can persuade my kids to keep learning. Once they have this thing with gamification, they say, okay, I keep learning, even they don't feel that they learn right now. But it's about getting new things in your mind afterwards to use or to execute with those new things. What we see is in Germany, just one of the last points of my keynote here is companies need to know what kind of company I would like in 2030. Once they discovered for themselves, okay, that's our strategy, that company is our goal to be in about 10 years. What they need is a lot of people with new skills to reach that goal. So it is very important that we have an education reskilling strategy within all companies. If not, we are sticking in the education sector of a company to our old strategy, and we are looking for skills within our labor what is not aligned to the strategy we have for the company. So it's important for company to figure out what I would like to be in 10 years. Afterwards, to figure out what skills, what profiles do I need for that goal, what I have. And then I need to figure out what's the right learning journeys for my people, for my labor. What's even the right journeys for students or young fellows, maybe attending or coming to the companies in the next years. But I need to know as a company what skills are the new skills I need in my company. If I'm sticking to things that I say, okay, AI is only for companies working or developing with AI, I won't survive as a manufacturing company in the field of mechatronics in the future. So we do have a lot of technologies. They are now crossing the field of mechatronics. Even in the first step, it sounds, okay, it's not important for us. AI is a big thing, of course. AI is a technology, a lot of times related to robotics, but is as well a 3D printing, AI, robotics, AI. So a company needs to know that we need to have people within our labor that are able to focus on AI, they are able to bring benefit to the customer or to the shop floor using AI. And this is what we believe is it's a combination of a lot of things in bridging the gap. It's explore opportunities, enable people, and having, for the last 3 pillars, what's important, the physical experience. It's not only about the digital content, so it's not only about learning, it's coming back to my example of a driving school, it's driving the car as well. So we need to have the physical experience. We need to use all the opportunities we have right now in the digital world, using platforms, reliable platforms, to get all the information and most of all using platforms and getting in touch with the community to learn effectively and to learn what are the success stories of other companies or other people we have. And that's about sharing. It's about sharing ideas. It's about sharing success. It's about being someone who's telling what I did and did it run well, yes or no. This is very, very important that we not only think in a digital world. Once we talk about Industry 4.0, it's about three pillars. It's about community, it's about the physical experience, it's about the digital content. So using technologies as an enabler to become one of the leading countries or the leading companies or maybe the leading talent. It is about people. It's not about a machine. It is about talent. It's not about a technology. And I do like to encourage you to think big, start small, but most of all, start. Thank you very much for the opportunity to having this keynote here. Big hello to India. Thank you.
Great, great. Thank you so much, Mr. Norman. It was really very, very insightful, and you very rightly put it in. It's Industry 4.0 is about people, because when we talk about the first thing which comes to our mind when we talk about mechatronics are all about mechatronics, machine to machine communication. But it's very important to understand. The more we explore, the more we tinker with the technology, the easy it becomes to us to understand, and then probably we can excel in that particular area. Very rightly said. So now moving ahead in the next part of the webinar, where we have lined up a panel discussion for you, and that would be led by Raj sir. And so over to you, Raj sir. And in between, whatever queries I'll capture it for you to ask to our panelists. So over to you, Raj sir, to start the panel discussion.
Sure, Varun. Thank you so much. First of all, it's nice to hear from PVG and also Mr. Norman, and privileged to have this kind of the responsibility today. So thank you, Electronic Skill Council of India, for bringing these eminent coordinates together. And so myself, Raj Bangapandu, I'm president of the European Center for Mechatronics and as German University and Indo-Euro Synchronization. And to start our panel, I would like to start in a very lighter note. This is the reason I heard from one of the amazing moderators from famous Hollywood movie, one dialogue, entertainment, entertainment, entertainment. I would like to import in our dialogue, reskill and upskill. Today's context, actually, as we are focusing one of the prestigious technology, mechatronics, and actually the sectors around it. And as Norman already shown some kind of white paper details from the World Economic Forum. To start about before the panel, I just would like to share a screen for a 90 seconds video of the benchmarking of the World Economic Forum, what it described of the disruption, reskilling, and also employability. So let me share my screen. Please give a heads up if my screen is visible.
Yeah, Raj sir, we can see.
seconds of our time actually given a glimpse of importance of in this particular technology. What are the different factors? Not only this, as indicated by the Technology Review magazine by the MIT USA, who works in advanced technology, it says that mechatronics is one of the 10 developing innovations that will change the world. On this note, and also by feeling responsibility on youth today, and as we are having the different various sectors of audience, the colleges, training partners, students, and SMEs and MNCs in the today's session, I feel privileged to introduce our panels, and I would like to invite all our 5 eminent panel members for today. So, our first panel member is Mr. KP Sharma sir, Vice President, Customer Satisfaction and Quality from Schneider Electric. KP sir, welcome to the session.
Thank you.
The second panel, Mr. Balgonkar, Head Regulations, Standards, Quality Management from Siemens. Welcome, sir.
Thank you.
And our third member, Mr. Harish Nanchani, National Sales Manager, Festo.
Hello.
And our fourth member from Germany, Professor Gunther Starke, Research Director, European Center for Mechatronics, Germany. Welcome, Professor.
Yes. Hello. Good afternoon from Germany.
And our panel member, Mr. Venkatesh Balasubramanian, Manager in Training, SMC Corporation India. So today we have
Thank you.
Feminine panel. Welcome, sir.
Thank you very much.
So great. I feel responsible to start with KP Sharma sir, to give a view of your views about the mechatronics and also from your company side, how you're feeling about this sector thereof and Industry 4.0.
Absolutely. Thank you so much, Bankat. And before I say something from industry side, also we welcome Electronic Sector Skill Council new CEO, Mr. Menon, and we are very happy to be seeing him on this chair. And even we have not met much, but we have heard a lot about his credibility in the system. And Mr. Menon, we also assure you, like, we are with you in your journey to make it sure, like, how we can take Electronic Sector Skill Council and specifically this Industry 4.0 through Mechatronics more in a successful way. So me, KP Sharma here, I am working with Vice President for Schneider Electric for GSC International. So in my country, we have about 100 factories, starting from India to Philippines to Batam to Australia to some in Middle East. And Schneider is a big organization which is working very, very aggressively on this Industry 4.0. So back to this topic, I guess Mr. Norman has given us a lot of insight on mechatronics, what's going on, skilling, what are the different issues are there, and what are the solutions there. And let me speak from industry perspective. As we see last 4 or 5 years, we are talking a lot on robotics, 3D printing, or artificial intelligence, machine learning, 5G connectivity, automation, and so on. But let me share with you, still there are a lot of discussion happening. I was there in CII a few days ago, and still people are thinking, what's going on? Who is really, implementing all this in the supplier perspective? I guess this work is going aggressively. For example, in Schneider Electric, we have about top 10 factories, which we call smart factories. And in India, in Hyderabad, in Bangalore, we have smart factories. And when we say the smart factories, it means already we are using the 3 to 4 layers of EcoStructure. Most of the machines are connected, and we have edge boxes. And then edge boxes, we are using data through machine learning or IoT. And then we are pulling all this data into a big data analytics. So we have our own analytics team. And then we are pushing this data into our big layer of data lake, and then different actionable strategy or actionable processes are there so that it's 360 degree close. So I strongly believe, this is the new world. This is the new era. This is the new way of working. And maybe at one side, COVID has given us a lot of challenges on personal and professional basis. But I guess it has given us a really triggered very hard how digitally uh, uh, can be very, very, beneficial for our industry. For example, during this COVID era, we created 4 5 digital towers where, for example, anyone sitting anywhere in the world can see like what is happening in Hyderabad factory, let's have what's happening in Bangalore factory. A simple example, I keep giving this example again and again. For example, in one of our factory, we have 40 station of torque driver. Can you imagine when one torque driver is tightening the screw, the torque which is getting applied to the machine in fraction of second, it is going to big data analytics and then converting into CP/CPK of those values. When we are seeing what's the how much energy we are consuming in each factory, how much energy we are consuming in each DC, and with the fraction of second every day we can find live, and then we can take some those kind of corrective action. We can see on the quality controls like what are the CTQs, what are the CTPs, what are the process PFME, RPN numbers in each station, in each site, and how we should take different action. We are seeing like how to do a preventive maintenance. For example, you might have seen Sika 2, where you go to the machine, scan the barcode, and even the machine repairer operator is not there. You can repair the machine with help of remote diagnostic, and you can see manless drivers, manless equipments. So what I'm trying to say is, in our factories, no, this is a reality. And now we are also making it sure with small scale industry. A lot of our suppliers are there. For example, we chose 50 suppliers where we can put this kind of digitization. For example, how to connect them through edge boxes, how to take this data even before material comes to Schneider. The data comes to us because it's all live. So I guess through Mechatronics, like Mr. Norman was also mentioning, one huge task in front of us is a reskilling of the people, changing the mindset of the people, because the people who did engineering 20 years ago, 15 years ago, we have to train them to the current mindset. And some of the students are there in this call, and my also request to you guys is, one, you go through some kind of theoretical things, but also find out what's happening in the industry, because digital is the new norm. Today, 60% of our job roles in Schneider Electric, we have changed in last 2 years. Means 50% focuses on what is your background on digitization, how much you know about analytics, how much you know about IoT, how much you know about sensors, how much you know about this SQL, etc. Because if you see a quality engineer or production engineer or a supervisor, earlier he was supposed to go data, he has to measure something. Today, 50-60% of his job is done through digitization, through IoT. Directly data is coming from machines and all. So I guess no more focus is on his analytical ability, getting those data, digital citizen, and all those things. So I strongly believe, like this through Mechatronics, we can play a big role. And from as I am also bearing a hat of chairman of Automation Sector Skill Council under Electronic Sector Skill Council. So we are also making it sure how to take this ecosystem from industry to the universities, to the Sector Skill Council, to the government. We were planning to put some 4-5 model automation sector skill institutes, which can create employable folks. So as my friends from Siemens are there, we were just thinking like at least take 5-6 industry, put about 500 people in those centers, and then make it sure all those 500 people are getting employed, and then make this chain powerful. So I guess let's make it sure all together how we can contribute to make it a big success in the industry. And one more suggestion which always I give: whoever want to visit Schneider factory in Hyderabad or in Bangalore, which is true smart factories, and we can see truly how those more than 5,000 sensors, how IoT is working, how robotics is working, how machine learning is getting converted in insight, how this is connected to big data, how actions are getting driven. So live, real time, we can see. And I will be the open with any one of you who want to visit those factories for your employees, for your students, or anyone in this electronic sector skill council. Thank you so much. Back to you, Raj. I know my other colleagues are also waiting, but if any other question comes, I can take up the email. Thank you so much.
Sure, sir. Thank you very much for giving such a nice insight at your company, sir, because the audience also can understand how it is going in the real scale with your company and what is happening. And also thanks for the opportunity, what the takeaway also we can get from the Schneider. And definitely students will reach Electronic Skill Council of India, maybe if they want some kind of industry tour or something to the Schneider. And we have one question, sir. KP, sir?
Yes.
We are audible. Yeah. So from the audience side, actually, we received one question would like to hear from you. What are the big technology disruptions with the potential transform digital manufacturing space through mechatronics, and how we are preparing for such disruption?
So I guess the big disruptions which are coming now, I guess maybe people call it 3D printing, and some people have already started calling 3D square printing, edge computing. And then as we are talking a lot about machine learning and all, I guess the big disruption is, for example, when Schneider is going to buy any machine, we are saying if it is connected, if it is cybersecurity protected. So it is going to be a big change even for our instrument maker, our machine maker, our jig and fixture maker. For example, a few days ago, one person came to us, hey, I'm making jigs fixtures for you from years. No one have told me like I need connected jigs fixtures. So I guess this is a big disruption and transformation happening where on the shop floor, machine, jigs fixtures, anything which we are buying now should be connected. And as it is also aligning with the strategy of the, like most of the all technology players, they are making connected products. So connected products, connected jigs, connected devices, connected machines. I guess this is going to be a big disruption because today, only 4% of machines or jigs or fixtures or equipments are connected globally in the factories. So it will be a big change for specifically for small scale industry to change to connected, to move to a this one. So I guess this is connected is one big disruption which is happening. Second, I guess the data, for example, because we need speed. So maybe 2G, 3G, 4G. Now, I guess even in the 5G, you can put IoT, you can put any damn thing, but if data speed, the connectivity is not so good, I think it will not work. So 5G is going to change a lot of things the way we are thinking today, this connectivity from edge boxes. In my opinion, two disruptions. One is connected as a big theme. Second, the connectivity through data. And anyhow, then you have small disruption happening everywhere. For example, when we started about robotics, right? One, okay, you can think about what robot can do. It can pick component and all. Today, the robots can do all end-to-end, repairing of the machines, detection of the quality. So, for example, we put one quality robot in one or two factories. It means it is detecting accuracy level is 99.99, G level is 4.9. So what I'm trying to say, these are the few disruptions which are coming. And I guess in big companies already we are taking action, but we will not succeed until our suppliers and downstream also deploy. And we are also making our efforts, for example, in countries where we are there, how to connect with supplier, how to help them, how to support, how to coach, how to guide, how to give more business to the people who are more connecting digitally end of the day. So I guess these are the few things from my opinion.
Absolutely. Thank you so much, sir, for the explanation, and definitely the eye-opener for suppliers also need to follow then to change the complete ecosystem. And thank you once again, sir. And I'm very happy to invite Mr. Belgonkar, the head regulation standards and quality management from Siemens. Sir, we also had some kind of very nice interaction and word of exchange in our last meeting last time. Very happy to invite to the panel, and would like to listen from you about this mechatronics in the era of Industry 4.0. Please, sir.
Yeah, thank you. So, over the past few years, Industry 4.0 is gaining prominence among various manufacturing verticals, both discrete and process industries. And the key promise is, of course, to be able to offer personalized product at mass production cost to customers. And this is where mechatronics comes in place, because it is going to transform today's workplace. So it is no more a machine, but you are able to connect a lot of things together. And also, what post-COVID, what has happened is when you are not able to work in the factories at a full-fledged capacity, you are supposed to operate only at a 50%, for example. And this is where, if we are having machines to enhance the productivity of a people, and that's exactly how mechatronics fits well into this place. So whether we are talking about pick and place, whether we are talking about gripping, whether we are talking about a special kind of a welding, so it's a blurred workplace now. It's an enhanced workplace, and this is where it comes. All this thing comes from your product knowledge, your production knowledge, most importantly. And how do you look at, like KP sir spoke about these 5,000 sensors, but do you know what is your process about, what parameters are critical to measure, and how do we analyze this, and how do I enhance the performance of productivity or even quality at the workplace? So this is where, so mechatronics is just only a way of making tomorrow's workplaces, but the basic fundamental problems will still remain the same. So it's about enhancing the productivity of the worker. It's about solving the variances in the processes. It's about looking at the quality or deeper aspect of the quality. So you are getting a data, much more granular data, because in the past, the whole data, because of the limitations of the sensors or people or even the measurement technology, you were doing, say, a batch kind of a data collection, and once a month kind of a post-mortem of a data. But now when with the sensors, you are getting much more granular data. You are getting data in a real time, and this is where the operator has to take dynamic decisions. So no more he has a chance to go back to his supervisor and ask him, what do I do now? So this is where in the tomorrow's workplace, he and machine, both of them, they have to coexist with each other. So they have to understand each other, and they have to work to make it possible that Industry 4.0's vision of making a personalized product at a mass production cost.
Okay. So everybody, we are very dedicated towards our Atmanirbhar Bharat nowadays. And so what are the key opportunities and challenges you see in creating this Atmanirbhar Bharat through the use of digital manufacturing and mechatronics? And what are the skilling demand do you foresee in this particular segment?
Yeah, so excellent question. One of the, whenever we talk to the small and medium scale enterprises, the first question, they're always saying no, not because of getting people displaced, but because of the huge cost. So the kind of impression they have, that I have to actually invest huge, I have to change all my machines. So nothing of that sort. So one can always begin in a brownfield factory on an existing machine with an existing problem. So like I was saying, if a specific machine has a problem in terms of quality, or if I would like to enhance maybe with some attachments, etc. So you can even begin with such a one simple workplace with a one simple challenge. And this is where the second part comes is you need to actually understand your operation finely, because when the data will start coming to you, it happened with one of the large company. They put a sensors on their own. They collected a data of last 1 year. And when they came to us and they say, okay, can you help us? And this is where the problem was, the data, even in spite of fitting a sensors, the problem was not defined properly. So the problem statement and the data, they were not matching each other.
Okay.
And this is where the challenge comes, is one needs to actually understand what is the problem, at the shop level. So is it because of the machine? Is it because of the supplier? Is it because of the material variance? Is it because of the skill of the person? So what is it? Why this variation is there? And this should be once this is understood, then you can fit in all sensors, start doing the data, and this is where the new skills what you are talking. So first of all, from Atmanirbhar point of view, my point is it doesn't matter whether it is a small or medium scale. They can always begin with the existing shop floor, with the existing machines, but please find that one critical problem which is going to differentiate you in the market, because now you have to differentiate in the market. So why are you there? Why your customer cannot replace you with somebody else? Why your customer cannot change you with a cheaper alternative, for example? Why he should not do it in house, but he can just buy maybe a better machine, and why he can't do it in house? So this is where we have to really very carefully think about what is our differentiation proposition, and then what is the digital value addition. Because today the whole value addition we are trying to do in the personal space, but how with this data, how can I add value to my customer? So it is not only adding a value to myself, to my processes, but how can I add value also to my customers as well? With whatever insights which I'm getting, how can I also pass on some of the value to my customers as well, or maybe to my suppliers, so that the whole ecosystem can benefit out of this. And that's why in terms of skills, if one has to understand working, so this machine to machine communication, so you have to understand and then fix this machine to machine communication, for which you need to know knowledge about, say, OPC UA, for example. It can be different kind of a communication technologies which will be required. So it is no more only mechanical, electrical, electronics, but you have to also understand all these other peripheries as well. You may have to work with, say, augmented reality, because while you are working on a machine, so you may, and you want to train about your machine, because physical experience, as earlier speaker said, it's extremely important. So from students' point of view, whenever you are, I know some of you are actually doing virtual classrooms, but please make sure that the physical experience, there is no substitute to physical experience. So you must actually work upon machines. You must have those kits which will give you this kind of insights where you are able to make mix and match. Depending on the problem, you are able to customize your solutions, and this is where, depending on whether the issue is from sensor side, whether the issue is from communication side, whether the issue is from the data analytics side, so different dimensions you should be exposed to. So no more it is good enough to understand only one topic of it, but all the different facets of this data, and to be able to differentiate in the marketplace.
Thanks for such a wonderful explanation. Yeah, as you defined, as mechatronics is defining tomorrow's workplace and quality and precision, and also everybody start looking at new component of improving, actually reaching the goal what we want to have as a nation. Thank you very much, sir. And now I would like to request Mr. Harish Nanchani. So Mr. Harish, we are also talking about this kind of the skilling and also putting the points together, and also you from Festo having the different didactic processes and all, doing different kind of activities. So please is up now is to use it to explain about mechatronics in the era of Industry 4.0, the views from your industry perspective.
Good afternoon, everyone, from my side too. I'm Harish Nachnani from Festo, India, and responsible for didactic in India. The topic I would like to give credit to the Secretarial Council, to link mechatronics and Industry 4.0 in a way, creating a topic is just wonderful, because we all know that mechatronic is actually the foundation of Industry 4.0, on which the complete, we can say, the Industry 4.0 is built. And how we move from the whether we say 2.5 in India or 3.0 in India to 4.0 in India is actually a important aspect. So I just have a few slides, not much, but what I will do is in the process thank Mr. Norman, Mr. KP Sharma, and Mr. Belgaonkar. So what they spoke, I tried to put it in some slides in a very simplistic form for our student audience mainly. So what is the mega trends that we are looking at? We talked about robots and cobots, about 3D printing, about artificial intelligence, about autonomous driving, and what is this actually doing? So this, what we really say is not actually replacing the job. It's actually replacing the activities that way. Yeah. So for example, it's an autonomous driving. The car has to be driven. Maybe the driver is not sitting in the car, he is sitting in some location somewhere and driving, for example. How we have an operator on the shop floor, we would still need an operator on shop floor with the industry 4.0, but his activities would be different. The way he would do his maintenance task would be different to what he's doing today. So we say basically it's replacing the activities and not the jobs. And therefore digitization in the true sense, what we say is bringing the change in value chain and the product life cycle, through which the real and the virtual worlds are merging together. They're growing together. Yeah. And in Festo, when we had industry 4.0 implementation, we had this chart prepared, and this is on one side showing the complexity of industry 4.0, on the other side really showing how that complexity can be managed that way. Yeah. And what Mr. K. P. Sharma said, or what Mr. Norman said, it becomes very, very important to see what is important for the individual organizations. In Festo, we say why the processes are important, because if you apply digitization to a broken thing, you will get a broken digital thing. So it becomes very important that you understand the process, and this is where you understand how you do a vertical integration and how you do a horizontal integration. What is it required? What is required for smart maintenance, how you are connecting your supplier to the plant, how you are connecting your customer to your product, how you are having a lot size one, for example. And in all these things, the competency development, the training of the employees, very, very important aspect of it. And this is why what we say is through this chart really explain out how to manage the complexity, and how we take about it. And as Mr. Norman also said, sorry, I'm repeating, but the human factor is the most important part. Even with a smart factory, the human factor is going to be the central part of it. He is going to work together with the machines. His job roles are, and the job requirements are changing. He has to have a relearning. He has to de-skill and reskill again. And have a lifelong learning aspect of it. So the human factor is going to be the absolute important part of industry 4.0, and that is what has to be really taken care of. Yeah. And this has to be taken care of at, when we say lifelong learning, at a very broader level. It could start with his academic training, it will start through his professional training what we has, and then it remains his fundamental and continued learning of how he is adopting digitization that is in his working environment. And that's how it becomes important that how industries like say Siemens, Schneider, Festo, us, SMC also on the panel, how we all can help in this path of change. And here what we feel is the sector skill council becomes very, very important, that they together bring in the technology leaders, they bring in together the service providers, the training providers, to say so. And then it becomes very important that how we transfer the knowledge to the society. The transfer of knowledge happens to the society in terms of, we say, on the academia on one side, but also on the industry on the other side. How they are upgraded in terms of the new technologies, the new products that are available, and how the qualification of the people can happen, that they are really able to implement the new technologies, understand the new technologies, select the right new technologies that they have. Like an example, a data collection, a sensor may collect so much of data. And an example, Airbus A380 flight, when it does an 8 hour of journey with 50,000 odd sensors on board, it creates something like 8 TB of data. Now do we have that resources, the processes, the other things to really, see and process that data and use it. So it becomes very important to do what kind of implementation that we would like to do, understand the processes, and therefore the qualification of the people becomes the most important aspect. And this is where, together with the sector scale council, this broader knowledge can be passed on to the society. So that would be a
Absolutely,
short
sir.
brief from my
Absolutely.
side. Yeah.
Absolutely. I mean, whatever the complexity of your chart is showing, definitely, and also we have young minds also. In a classroom, they are sitting and actually watching us. So I can like, very happily also refer them actually from the Hyderabad, Telangana, from Synchroserve, actually the students sitting and watching us. And by now, students, you already got a very beautiful point from the, because we actually at the mid of our panel discussion, and from one of the eminent panel, you actually came to know about disruption, and from second panel member you came to know about actually how quality precision is also important for actually defining tomorrow's workplace. And also, as Mr. Harish just mentioned, the human factor is very important, as Norman also referred. And as you see in the World Economic Forum benchmarking video, the 50% of employment actually, they are doing the reskilling and reworking, and this kind of eminent speakers inputs are going to be create some kind of a building blocks for you to bring together and to take it forward. And in this similar context, Ms. Harish, we have one question to you. What are the sector specific skill gaps and strategies to promote skilling in mechatronics and digital manufacturing?
Okay. If we say sector specific skill gap, I think skill gap is actually, across the sectors, and especially when we talk about electronic sectors council, or we talk about automation sector skill council, it's a segment where it is really cross sectional. It's going to, different industries, and the skill gap is available, is currently there in all the sectors. Yeah. What we really see in terms of skill gap, we can see it from two perspectives. On one side, it could be the skill gap related to the industry related topics. It could be the technology related topics that is important, that is lacking. On the other side, on the human factor and other aspect, what we really see as a skill gap largely happening is to understand the larger process, to understand the process from a broader perspective, in terms of interconnectivity, and understanding the complexity of interconnectivity. Yeah? So this as a skill gap, definitely it exists. We can also look at skill gap from one another perspective. What we can say from Festo side is the larger dilemma of differentiation between the larger companies and the SMEs. Yeah? The larger companies by themselves are definitely having the resources and the expertise to implement topics of digitalization or Industry 4.0. The challenge is happening with the SMEs, where on one side is the resource limited ability of the resource in terms of manpower, their qualification, and their part, or on the other side, in terms of investment resources of what they can take care of. And third, comes to my mind, is also, if we can see it as a skill gap arising in a country like us, where we have the kind of trainers available that they can impart training to this segment, covering these new topics, that way. So we would see this skill gap from a larger perspective on the technology side, on the human side, between the SME and the larger companies, and also the availability of the trainers, that way. Yeah.
I mean, very good points that you mentioned, skill gap and in SME and MSME sector, and also trainers availability. This is what exactly Electronic Skill Council of India or Skill Council is actually, delivering through the training partners. I think the students also who are sitting in the classrooms and actually watching the panel now, so they will be also understanding. So you are the people who are taking the some support and coordinating the points what sector skill council is actually offering through the training partners, and to really addressing these kind of skill gaps and reaching the demand of the market. Thank you very much, Harish sir.
In this just extension, just one small aspect, it's also important how we address, this skill gap side of it, that way. So of course, looking at the industry related trainings, looking at, the technology related trainings, these all things definitely happen, can take care of, we can do train the trainers. But one important aspect that we would like to share is, and that's a challenge globally, and is there is a lot of inhomogeneous standards and skilling practices that is happening, globally. And this on one side is making it difficult to transfer knowledge on one side to the participants, and also on the other side to do the right kind of assessment, part of it. And that's why it becomes very important that we learn from countries like, say Germany, Singapore, who have a much larger case studies of implementing such topics, that we try to create some homogeneous standards. It becomes very important, then it becomes a sort of a benchmarking at a level which has been implemented and cross examined, and then we see it for our Indian environment, how we can adapt it to our environment. And this standardization, together with the digital part of it, linking it with the digital content, which becomes very important in today's environment, of how we can have the hardware and the digital part coexist and work together, and this can help to prepare the workforce in a much better way.
Oh, absolutely, sir. It is like adaptation to the requirement from the experienced platforms. Yeah. So thank you very much, Mr. Harish sir. And on the same note, maybe I would like to go to the another country, to the Professor Starke. So I'm very happy to invite Professor Starke to address the session. I think this is the right time also to understand and to listen from him. What actually the practices and their view of doing mechatronics from Germany, from his decades of experience. So can I welcome Professor Starke to address this part?
Yeah. Okay, I'm here. Unfortunately, I lost my video screen. Yeah, can you switch it on from your side?
No, Professor.
Okay. Yes. Here I am again. Thank you so much for your introduction. Yes, first of all, a special hello and good afternoon from the western part of Germany. Yeah, instead of snow in south, okay, we have a lot of rain, temperatures around 3 degrees above zero. And okay, this is the situation. Okay, I'm sitting at home, okay, as it is given by our government, stay at home. This is the the point for the moment. And okay, I would like to give you some aspects related to the education in mechatronics, and especially with a view on the German situation, as you mentioned, Raj. Yes, if I look back, okay, we have to go into 1918 and between in this decade, 1918, 1990, okay, where the companies found, okay, we need a little bit more than pure mechanical engineering. We need mechanical engineers which have also skills in electronics, which have some skills in computer technology, and which do understand, okay, the interaction between the systems in a machine. For instance, at that time, intelligent production machinery comes up. We saw advanced automation equipment based on these interdisciplinary engineering of mechanical, electrical, and computer technology. And even in the consumer goods, okay, we saw intelligent functions, smart functions, as we call it today. And this gives us the idea, and this was the demand of universities, okay, to extend the study programs for mechanical engineers in terms of more knowledge related to electronics and computing technology and to their interaction inside a system. So that means one of the first universities which started with this mechatronic study program was in my state, in North Rhine-Westphalia, in 1991. This is long ago. And okay, a lot of students came up and they had been interested to start into this new approach of engineering, to get a more or less more universal knowledge based on the three disciplines, as I mentioned. So, and many universities followed through the years. In 1994, my company, the APS company called European Center for Mechatronics, was founded, also with the motivation to enhance mechatronic research and to bring this results of this research into industry. In parallel, the universities in Aachen started with a mechatronics study program, especially my university where I'm lecturing as a professor. This was the University of Applied Science in Aachen, and they started in 2000 with the mechatronics study program. And this study program normally is split into parts. The first part is to receive the bachelor study, the bachelor degree, and the second, of course, for those who are more interested in advanced knowledge related to mechatronics, they have the possibility to study a 4-semester master program. So, and of course, you can imagine the curriculum of this study program is a mix of mechanical, electrical, and information technology. You will study the fundamentals of mechanical engineering and electrical engineering. You will learn about microtechnology, how to develop and build microsensors, for instance. Another point is to study analog and digital control technology. You will learn, okay, how to use sensors in combination with actuators. Even advanced mathematics is another subject, okay, which is important. And of course, the understanding how the systems inside a mechatronic system are operating together, are interacting. Therefore, system engineering is very important subject in this mechatronic study courses. Yeah, one of the important system which is related to mechatronics and which is representing the mechatronic idea is, of course, the industrial robot, as we know. There we have mechanical design, we have electronics, we have computer technology, and we have a mix of all the systems to make the robot running. Therefore, robotic systems is also an important subject in this study program of mechatronics. If we want to develop very powerful mechatronic systems, of course, we need certain tools, and one important tool is the simulation. Therefore, mechatronic system simulation is also included in this course program, as well as motion control, and you can select other modules where you are interested in. And through the years, okay, especially in FH Aachen, okay, at the university campus, we saw a lot of students coming from foreign countries. We don't have only German students which are interested in this new mechatronic study programs. Many students also from India, especially from Mexico, from Portugal, from Spain, from UK, they visited Aachen for 4 semesters or 7 semesters bachelor, okay, to study mechatronics and to receive the bachelor or master degrees in mechatronics. And why do they come? Because they found there is a special job opportunity if you can present mechatronic engineering competence. And this can be also found if you are in contact with industry. There had been a lot of discussions in the past where we saw from industry the special demand, okay, to have engineers with complemented skills, complemented in terms of mechanical, electrical, and information technology. So, and if you look into the car industry was one of the first who recognized the special benefits of mechatronics. Keep in mind, okay, there is automatic gear, there is anti-blocking system, adaptive dampers, speed control. We have the motor management. Meanwhile, okay, car integrates certain assistance systems. We have electronic stability program and traction control, and so on and so on. That means all the developments coming up, especially in the automotive industry, are related to mechatronics. That means, okay, there is a special need, you can imagine, and there is a big motivation from student side to go into this direction and to study mechatronics because of the excellent job opportunities. And if we look into the future, what do we see? We see mechatronics, as we learned during the session also, is one of the essential parts in Industry 4.0. All the developments, all the vision we have in Industry 4.0 are more or less based on this fundamental knowledge given by mechatronics. And especially in the in the next years, what do we have? Okay, we will have smart systems, smart products. We will start into micro mechatronics because what do we see? All the things, the products become smaller and smaller. Microelectronics is the driver. And the next step will be in future nanomechatronics, small systems which can move into our body to make some inspections, small robots. This is really the vision of mechatronics and of the medical people. Of in parallel, automation, it's a very, very big business, as we mentioned, also in the previous presentations. Medical devices are based on mechatronic approaches. In automotive, what do we expect? We see the self-driving cars. We see systems which have the capability to decide themselves related to the environmental information given by sensors. We see intelligent traffic. That means for students, there are really a lot of promising fields, okay, to use their mechatronic knowledge. So that means, in principle, mechatronics is meanwhile the core of our life, and we have excellent job opportunities, particular in manufacturing, in the manufacturing industry, but also in producing consumer goods. And from my side and from the educational side, okay, I can really recommend to study mechatronics and to start a very promising career in this area with this mechatronic background. So it's a perfect chance for students, especially here in Europe, and foreign students are really invited to come here if they don't have the possibilities in their own countries for the moment, okay, to go into this mechatronic study program and to get this knowledge. So very, very short from my side, some aspects related to education. Thank you very much, Rad. Back to you.
Thank you, Professor. And we are very happy to connect, and also your referral to the first mechatronics study program is started in Aachen. And today we are happy to have a speaker from that location. I excited, and also I can understand the importance of
The line is.
This is the maybe I'm repeating my last sentence. So when you mentioned about a small robot is going inside of the body and doing the inspection, I was actually like a student. I was imagining how it is going and how it is happening. So it is like a vision of the mechatronics, and also the change in our lives that are happening to the mechatronics. Thank you very much, Professor. On the same context, of course, you have decades of experience by seeing international students and also Indian students in Germany. There's always a fear about jobs, Professor. So there is like a fear about that automation will replace human beings in some of the low-end jobs. What are the learnings from the past decade about this fear while automation in full swing across the world or across the industry? So what is your observation? Is Germany lost a job, or world lost a job because of the automation, and how the things have changed?
No, I think in the automation business, especially in Germans and the neighbor states, as we can see for the moment, okay, are very, very promising. Okay. Very skilled people, very skilled young engineers are used in a lot of different industries. And I think especially the job opportunities are very, very good for the moment. Because automation is increasing, okay? Even industries which are very traditional in the manufacturing concepts, okay, they see the competition on the worldwide market is getting stronger and stronger. Therefore, they have to do something. And one solution is to start into automation, to use robots, to use automation infrastructure related to Industry 4.0 vision. And therefore, I think, okay, for the moment, many young students, young engineers are demanded in industry, especially in Germany. Car industry is looking for engineers. And due to Corona, it's for a moment, it stucks a little bit, but we believe, and we are very, very hopeful, but in the second half of this year, okay, the business is coming up and gets stronger as before.
Absolutely, absolutely. So thanks a lot, Professor, for your insight. Yeah, I also would like to add one line here. And always this kind of technology shift will happen. And the students and youngsters and the SMEs and the industries definitely need to adopt this shift and need to welcome the new technology. Especially for the students and also the teachers who want to tell their students, automation is not definitely going to kill all the jobs. It is actually upgrading the jobs. One example could be in the similar kind of the fear when we are having a computer into the banking sector. They are saying that, okay, we'll be losing all the jobs, and banking sector, the computer actually we are allowing. So now can you imagine without a computer in the bank? Can you imagine our app, and can you imagine without an ATM machine? So in a similar way, we no need to fear about the automation actually coming and killing the job. So it is our responsibility to upgrade ourselves. And maybe in the same note, I think we have a senior manager of trainings, Mr. Venkatesh Balasubramanian from the SME Corporation. I think he's the right person to, in this context, to share about the mechatronics in this era and also to address it. Sir, over to you.
Thank you very much. Thank you very much, Mr. Raj. And I would like to thank, first of all, Electronic Skill Council of India for giving us this opportunity to share our views with the people across the students, the industry across India and across the world. So I also would like to congratulate the previous speakers for wonderful insights into mechatronics and Industry 4.0. So as far as I'm concerned, I would like to share my screen and show a small presentation before I proceed further. So yeah, so I hope my screen is visible.
Yeah.
Yes,
Yeah,
yes, Mr.
yeah.
Reddy.
Thank you. So I would like to start by saying that Henry Ford once said, if you do the things the way you've always done, then you will get the same thing which you've always gotten, right? So if you don't evolve yourself, if you don't change yourself, if you don't upskill yourself or reskill yourself, and if you want to be current in the present situation, if you want to stay relevant in the current conditions, then you got to upskill yourself, you got to reskill yourself. And this is the moment, this is the time when people need to reskill and upskill themselves, because the technology is changing, there are new technologies that are coming in. And the millennials, they are very savvy about technology. So the people who are of the older generation, they need to understand what exactly these technologies are, how do they work, and how to integrate them. So as far as SMC is concerned, we follow this pyramid of automation. So ever since industry has come up, ever since industry or automation has started, there has been integration of these classical technologies of mechanical engineering and electronics engineering, along with along with the control technology or the computers or the information technology. So all this integration of technologies has built up this pyramid of automation, which has got 5 different levels. So the first level of this pyramid of automation talks about the field level devices like your sensors, your actuators, your hardware, which are actually which are actually doing the work and getting you the information. This information is further fed into your second level, that is called the control level, where you have your PLCs, the programmable logic controllers, your PCs, your proportional integral derivative devices, etc. Which collect these information and then feed it to the supervisory control, which is the third level, where you have the SCADA network, where a person is sitting at a central location. A person sitting at a remote location can monitor exactly what is happening in the factory, and he can change the settings of the inputs, and change the settings of the sensors, and what information he actually requires. And all this is controlled using the manufacturing execution system, MES software, and finally the enterprise resource planning, or the ERP system. So at SMC, we have the didactic equipment. We have developed these didactic equipment to cater to each and every level of the automation pyramid. So why do we need the SMC competence center? So because different industrial sectors, as I said, they're moving towards the automated processes. They're making automation as a part of their workflow. So the manufacturing companies or the industries are demanding skilled workers. So they need skilled operators. You need upskilling, you need reskilling, and to understand these technologies and operate these technologies. And we, as the world leaders in providing this solution in the global market, in the business of factory automation, we really understand the need of the academia or need of the industry. So SMC International Training, we have has specialized in identifying the skill demands. We have tried to identify the skill demands of the industry. We have identified the skill demands of the academia. We've tried to analyze the skill gap that is there, and try to bridge the skill gap using these kind of didactic training equipments. So because the technical colleges and the universities, they require the expertise and support from the industry leaders to satisfy the demands from the community. And also as SMC, at SMC, we want to contribute to this demand, by structuring a very powerful program, providing international certification in automation and mechatronics. So I believe that the SMC Competence Center will help in, help in teaching these different technologies which are going to come up in the next decade or so, like your artificial vision, your automated systems, continuous processes, electric motors, robotics, sensors. So all these technologies are disrupting the world today, and there are various skills associated with this which the students are supposed to know, they're supposed to gain. So these kind of didactic equipments that we offer can help them in acquiring these technologies, or acquiring these skills. And how do we do it? The methodology that we adopt is using blended learning techniques, like Mr. Norman Weiss had already brought out. Blended learning is very important technique, which provides the perfect combination to to accomplish the training objectives. Then we have highly interactive e-learning modules and state-of-the-art training equipment. We also have online assessments of the fundamentals and skills evaluation. So all these kind of training activities will give a holistic kind of learning to the student. So these are some of the training equipment that we have, which will help the student or the technician or the worker who wants to upskill himself, who wants to learn the new technologies, the technologies of mechatronics, of Industry 4.0, and become upskilled or reskill himself. So who are the winners finally? So during the process, the colleges, the industry, they have return on investment. They invest on the training of their workers. They invest on the training of the students, and they, they have a prestige. They get a prestigious name because the student is doing well. They've been placed well. There is an international network. The competence center can be achieved. And the teacher can get upskilled himself. Like we have the train the trainer concepts, so that the teacher himself can get upskilled. A certification can be given. So they are training themselves to the international standards. And students, of course, the skill development is there. They get a program from a reputed organization, and a certification which is of industrial international standard. So I welcome everybody to this, the new future, to the new technology, and hope this technology, the people that, embrace this kind of technology and learn new things, so that we make ourselves future ready, and an Atmanirbhar Bharat can be, created. Thank you very much.
Perfect, with meditation. Welcome to the future, and let's go to the future. Great. I have one question from because of the COVID and all we are having, right? So one framed question actually I received to ask you. So what are the major issues that the industry has faced in the COVID pandemic on the account of disruption seen in the supply chain and non-availability of the various components? Also, tell us the changes that have been adopted, planning to go forward to ensure minimum impact of such a crisis, because nowadays new problem is coming on a daily basis. So how we should be ready for that?
Well, that's a wonderful question. Thank you very much, first of all, for that question. So what I would like to say is, history will remember this COVID-19 as a pandemic, which is a black swan event, one of the black swan events, and even worse than the your Great Depression or the two world wars that we have seen. Right. So it is one of the events which is most dreaded if we reminisce of this at a later date. So there has been global interconnectedness. The supply chains are all interconnected. Like even we are exporting, we are importing from other countries. So all the supply chain was broken during the era of during this period of pandemic. So the imports were stopped. The customs were not cleared, and we had even health issues of workers were there. So all these things had to be addressed before restarting ourselves or kicking back into work. So what we did was first address the issue of the workforce. So the people, as was brought out, always come first. So the health of the worker is very important. Our management took all the steps during the period of pandemic to set up all the separate cabins so that people can sit at safe distances. Then you had automatic dispensing of all the alcohol based your sanitizers, and wearing of masks were made compulsory. Then non-contact thermometers were installed, and the biometrics were made touchless and all that. So all those things were first set into place, and then we started off with 100% attendance at the sprung back into action almost by mid of May. And we also incorporated the digitization. So as we are talking about digitization, we incorporated digitization, not only training, we incorporated robotic process automation. So that has been effective quite a bit in the and that has helped us in improving our sales, improving our customer satisfaction. And digitization, the training aspect, like we have virtual classrooms were set up. We have remote labs set up where the student can remotely access the lab which is at our centers, training centers. He doesn't have to come to the training centers. Then e-learning facilities were set up. Professionally designed e-learning packages were made, not only for our engineers, not for our customers also. And in fact, gamification was one of the biggest thing which we also launched for our sales engineers, where the sales engineers were, because they were sitting at home, they were devoid of all the latest developments that is happening. So the gamification software was launched. They, and also they were continuously learning new things. They were acquiring the knowledge through that gamification. They were, that competitive spirit of learning and competitive spirit of gaining knowledge was there. So all these things were being done during the period of COVID, and after also now that we are into we sprung back fully into action and 100% attendance is there. We are digitizing our physical entities. We are digitizing the processes in a big way. And in fact, I would also like to tell that one of a new factory was also inaugurated at Ahmedabad, and a lot of jobs were also created for youngsters. A lot of ITIs, diplomas have been recruited on a new plant in Ahmedabad, and that way we've also helped in creating jobs and helping towards Atmanirbhar Bharat.
Okay. That's really great, Mr. Venkateshan. And I'm really happy to see that today's panel giving a lot of insights towards mechatronics, towards the learning perspective. And before actually, I think we are over the 5 minutes or 7 minutes. Sorry for the audience, but I see that the 7 minutes is definitely going to work. Before I conclude today's session, I'm really happy to see how the youngsters and youth interacted and they listened to us today. Let me share my screen and show what are the different states of India connected today to us and how the youngsters connected to us. I'm super happy to share my screen. Just a sec. To all the panelists, okay. Okay, I hope my screen is visible. You can see the students connected with this seminar or webinar across the India from the states of Bihar, Telangana, Andhra Pradesh, with Skill India logos. Congratulations, students. I hope we able to bring some nice coordinates, and we definitely should thank Electronic Skill Council of India and our training partners to make use of this wonderful opportunity and take the nice, insightful points from this webinar. And I'm very happy to conclude the panel. Thanks a lot once again, the eminent panel members. And as we are having our audience across the country, being a training partner and students and colleges and small and medium scale industries, I would like to conclude with just a very small sentence among the all. So from KP we had a very great insight, and already being an industry and also chairman of Automation Skill Sector Council of India under the Electronic Skill Sector Council, he is actually supporting the standardization. So training partners in the mechatronics, your takeaway going to be new QPs are coming, new standardizations are coming, new courses are coming. So you are responsible to share this vision to our India. And also for the students, you listen from our national speakers and also international speakers, the courses and certifications, and also the new era of learning technologies, and also in the digitalization, how we are proceeding. You do it. Let's connect for that. Colleges, I think you listened from the person directly from who started mechatronics course in Germany, and from the dual degree courses until the course certifications, and also the industry customized vocational courses what Electronic Skill Council of India started. Let's connect. And small and medium scale industries, you are also the people who need to upgrade, who need to look for some kind of a room for improvement. As Mr. Balgonkar actually mentioned, the tomorrow is here, and let's start some kind of thing and also connect the dots towards the MNCs. Let's connect. So in this way, not only connect youth on a special occasion of the National Youth Day, connect, concentrate, and conquer. And I hope I'll be concluding my panel with this note again: connect, concentrate, and conquer. Mr. Varun, to you now.
Great. Thank you so much, Raj sir. Great, and really nice to listen, and such a variance of audience we have, and Thank you so much, everyone. Each one of you really is a key stakeholder in our journey of skilling what we aim to do. Starting from our training partner who have today arranged a lot of, they have outsourced this webinar to deep down villages, to rural areas where students were not able to get proper connectivity. They have taken the onus, in arranging this webinar at their center. So we are truly touched, and thank you to each one of our training partners, first of all. And what Raj sir very rightly said, so you are the one who gonna, we all gonna work for the students of India. And as Youth Day is there in India today, youth are the pillars of the nation. We all believe in the power of youth, what youth can bring to the country. So joining hands with the panel experts that we have, starting from Raj sir, he was able to arrange in such a beautiful manner. Thank you so much, Raj sir, for conducting this webinar and the panel discussion. Thank you so much. Special thanks to people from Germany, Professor Dr. Norman Weiss. Thank you so much for sharing your thoughts, your vision. It was really nice to have a presentation, and you given a very insightful thought to all of us. My special thanks to all the panel discussion panelists we have today. Mr. Harish Nachnani sir from Festo, KP Sharma sir, he has left. He had some other meeting, so special thanks to him. Um, Mr. Manoj Belgaonkar from Siemens, thank you so much, sir. We are very grateful to you. Even Siemens has done an MOU with us, and we are bringing a new Mechatronics BWalk program, which Raj sir also mentioned it. And there were many questions related to that. Like many people want to know how they can do the upskilling program if they want to learn mechatronics. So we are bringing a new BWalk curriculum for under the UGC approval. It's already been uploaded on the UGC website. So all the colleges and all the training partners, you can affiliate if you want. And it's been association with Siemens as well. And we have got the experts from various other industries too. And special thanks to Venkatesh sir. I really liked your presentation. What you really said about the mechatronics. It's not only about the machines. It's about the people, how they understand the technology, and like the more they understand, the better it becomes. The easy it becomes for all of us. So really, thanks to all of you. And last but not the least, the whole ESCCI team, Karishma, Isha, and all of you. Thank you so much for connecting. And we look forward for all the further series of webinar that we're gonna conduct in the upcoming days. And like we have today, audience from various of the stakeholders, we're gonna have more of it, and we look forward for your continued support and participation. Thank you, and God bless you all. Thank you so much.
Thank you. Thank you.
Thank you very much.
Thank you.